Okay, for this video, I'll be going through pure physics, turning effects of forces or moments, success criteria A and B. Okay, so success criteria A, describe the moment of a force about a pivot in terms of its turning effect. So a moment is also its turning effect, and relate this to everyday example. And success criteria B, recall and apply the relationship moment of a force, or sometimes we call it torque, is equals to the force times perpendicular distance of the force from the pivot to new situations or to solve related problems. Okay, you have learned in a previous chapter that a force is either a push or a pull, right? That one object exerts on another, it can make the object move up, down, left, or right. But however, if the force is exerted on an object which has a fixed point, sometimes we call it pivot or fulcrum. Okay, this force can turn the object either clockwise or anti-clockwise. So this clockwise and anti-clockwise is a different direction from up, down, left, or right. So basically, this is the turning effects of a force. So this turning effect is known as a torque or moment. We use moment more frequently. Now, examples of moments will be opening doors, turning on taps, and ceiling fan turning. Okay, the moment of a force is the product of the force F and the perpendicular distance D from the pivot to the line of action of the force. So this is the definition of moment of a force. Okay, so this is the definition. I'm going to explain some terms over here. So the moment is the product. Product means multiplication. Okay, so what do we multiply by? We multiply the force F, right? And the perpendicular distance D from the pivot to the line of action of the force. So there's a lot of words that I need to go through here. So what is the line of action of the force? Okay, so if I have a force that is drawn like that, which is either up, down, left, or right, or diagonal, which is basically a straight line, what you need to do is you use your ruler and place it on the force, and you draw dotted lines to show that these are the line of action of the force. Okay, so it's a very simple step to do, but it will help you later on. Okay, so whenever you see a force and you see pivot, you're dealing with moments. Okay, very importantly, if you see things like pivot or something turning, it must be a moment. Okay, so for every force that you identify there, you need to draw the line of action of the force. Okay, as we go through more examples later, you will see the importance of drawing the line of action of the force. So once I draw the line of action of the force, I then can find the perpendicular distance from the pivot to this line of action of the force. Let's use this as an example. So the pivot is over here, right? Which is a fixed point. Now, a force is being applied here. So the dotted lines have already been drawn. This is the line of action of the force. So this is as if I have the pivot, which is a point here, right? I have the line of action of the force. So how do I find the perpendicular distance of this line of action of the force to the pivot? Okay, actually it's a very simple concept. The perpendicular distance, okay, which is this, is actually the shortest distance of the line to the point. Okay, I repeat, the perpendicular distance is actually the shortest distance between the line and the point. So the point is the pivot. The line is the line of action of the force, and the perpendicular distance will be the shortest distance between the point and the line. And it happens to be perpendicular. Okay. So in moments, the most difficult part is identifying or determining the perpendicular distance of the force to the pivot. Okay, and by drawing your line of action of the force, it will help you a lot. So the formula is moment equals to force times perpendicular distance. So sometimes you use F times D. The SI unit for force is Newton. The SI unit for distance is meters. The moment will be Newton meter because it's a product. Okay, so you need to memorize this formula. You need to memorize the definition, and you definitely need to draw the line of action of the force so that you can find your perpendicular distance. Okay, now take note, SI unit of moment is Newton meter. Okay, but it can also be expressed as Newton cm. And from the definition of moment, we can see that if a force is increased, the moment will also increase. And if the perpendicular distance from the pivot is increased, the moment will also increase. I will use the formula to explain this. Okay, if I have a large force, then my moment will increase. If my perpendicular distance is increased, my moment will increase as well. Now, a moment is a vector quantity, okay, which means it has both magnitude and direction. The direction is now either clockwise or anti-clockwise. A common mistake when we ask students for the direction of the moment, they put to the right, to the left, up or down. They are talking about the force. But the force is no longer just a force when it's applied to an object with a fixed point. It now becomes a turning effect, and that is what we known as the force, the moment, sorry. Okay, so we'll go through this. B1, an L-shaped rigid lever arm is pivoted at point P. Pivoted at point P, this will cause us to think that we are dealing with moments. Okay, so very important, we need to identify where is the pivot. The pivot is here. Why is the pivot important? Because the pivot, okay, serves as a reference point. Okay, so why is this important? By serving as a reference point, then we can determine the perpendicular distance of whatever force to the pivot. Okay, so this question a bit complicated at first. We have 6 forces acting on the lever arm. What is the magnitude and direction of the moment? Because moment is a vector, so you must know the magnitude and direction of each force about point pivot P. So the pivot P is now the reference point. So all the forces must have their perpendicular distance determined with P as the reference point. So we can start off with the 40 Newton first. Okay, 40 Newton. Okay, we see that the pivot is here, right? If I were to pull out this diagram, I ignore all the other forces at first. We see that this 40 Newton has its line of action passing through the pivot. So there is virtually no perpendicular distance, right? As force or as the force or the line of action of the force passes through the pivot. And since perpendicular distance is 0, and based on the formula, moment equals to force times perpendicular distance, I have a force, but my perpendicular distance is 0 with respect to the pivot. Therefore, my moment will be 0. So, very simple, 40 Newton will have 0 Newton meter. Okay, and we don't even need to determine the direction of the moment because there is no moment. Okay, how about for the 50 Newton, same thing. If I were to pull it out over here, the pivot is here. The 50 Newton and its line of action of the force actually passes through the pivot, right? Remember the first thing that you do when you're dealing with moment question, you have to draw the line of action of each force. So if this is 50 Newton, it passes through the pivot. There is again no perpendicular distance and therefore no moment. Okay. Then we look at this 1000 Newton. I purposely increase the force to 1000, but because it is still not it still passes through the pivot, right? You draw the line of action of the force. It still passes through the pivot. So again, there is no perpendicular distance. Okay, so I will say perpendicular distance of line of action of force to pivot is 0. Okay, and therefore moment equals to 0, right? Okay, let me clear this up. If you understand the 50, 40 and the 1000 Newton, we can go on to do the 5 Newton. Okay, so the 5 Newton, the pivot is here, 5 Newton. What's the first thing that you need to do? Draw the line of action of the 5 Newton. Okay, so it can be very confusing here because there are so many lines, so many dotted lines, right? And so I can just imagine myself putting my pivot here, okay, and my 5 Newton is somewhere here, correct? I try to draw it as close to the to look like the diagram as possible. I have my line of action of the force. So because the difficult thing that students face is finding the perpendicular distance. So this is the point and this is the line. The shortest distance will be the perpendicular distance. So if I were to apply this back to the diagram, I'm looking for something like this, right? Which is the perpendicular distance. Yes, I'm looking for this. So the perpendicular distance for the 5 Newton is 3 meters. Why do I write the 3 meters beside the force? Because as you recall, moment equals to force times perpendicular distance. So I have my force, I have my perpendicular distance. I can actually calculate my moments. But wait a minute, I think there's an error here. Okay, because this 3 meters is from here to here. Okay, and this is 1 meter, so this entire length is actually 4 meters, and from here, from the application of the 5 Newton force to the end of the rod, it is 2 meters. So sorry, the perpendicular distance is 2 meters, okay, for this 5 Newton. Okay, so then you multiply them together, you get 10 Newton meter. We'll talk about the direction later. Let's do the 10 Newton. Okay, again, it's a bit messy, so let me remove some stuff and just focus on the 10 meters. Okay, so again, 10 Newton is here. Not 10 meters, 10 Newton. The force 10 Newton is here. I draw my line of action of the force for this 10 Newton. That means for every force that is present or acting on the rod, I need to, if there are 5 forces, I need to draw 5 line of action of the force. Okay, and drawing line of action of the force is easy. Again, we take a ruler and just extend the force front and back. Okay, so again, can be quite confusing, but I'm going to try to replicate this. This is the pivot, and the line of action of the force for 10 Newton is this way. So I want to determine the perpendicular distance, which is the shortest distance, right? So this is the perpendicular distance, so I'm looking for something like that, and I match it to this diagram here. So the perpendicular distance is 2 meters. Agree? So if it's 2 meters, then the moment is 10 times 2, right? Because moment equals to force times perpendicular distance, so I get 20 Newton meter. Alright, so for the last one, let me clear this up. 20 Newton. Okay, so you should be trying to get the answer yourself before you continue watching. So 20 Newton is over here. The force, again, I draw my line of action of the force. So these are tiny details that you can apply to help you, right? So some students still refuse to draw this line of action of the force, and they always get their perpendicular distance wrong. Okay, so again, very confusing. Let me put my pivot here outside. Okay, and then this is my pivot. My 20 Newton is somewhere here according to the diagram. My line of action of the force is this way. Okay, so this is actually the shortest distance, and this is my perpendicular distance. So I'm looking at something like that, which corresponds to the 3 meters. So I'm going to write my 3 meters here. So then multiply them together, it will be 60 Newton meter. Okay, now for the direction. Okay, so there's this pen trick that I teach, right? You try to hold a pen, right? And because this rod, I can say that the pivot is over here. And for this 5 Newton, it is applied to the, let's say you have a pen. Okay, you hold the pen here because the pivot is obviously on the most extreme left hand side. So you hold this pen here, and the 5 Newton is applied to the right of this point, and it is going upwards. So as you push your pen upwards, like trying to simulate the 5 Newton going upward, you'll see that this thing actually goes anti-clockwise. So the moment for this will be anti-clockwise. Okay, so we are going to do the 10 Newton. The 10 Newton, you will have to actually imagine holding on to the pen here, like this. Okay, so the pivot is here, the 10 Newton is here. Okay, so some of you may say, but this is an L-shaped rod. Okay, then what if I extend the rod, I make the rod to look like this? It's actually about the same, isn't it? It's actually the same, right? By shortening, because the force actually passes through like that. So if I shorten this rod, the pivot is here, my 10 Newton is like that. So it's as if I can hold the pen, I can hold my pen here, right? And I apply a 10 Newton force here. Okay, so if you apply the force below the pivot and going to the right, it will be going in a anti-clockwise direction. Okay, finally, for the 20 Newton, okay, I will take my pen and I will hold it at the end on the left hand side, right, according to the diagram, according to the question. And 20 Newton is applied here on the right hand side and it's going downwards. So I will hold my pen over here, example my pen here, I will apply a downward force of 20 Newton and this will result in a clockwise moment. Okay, so this is how you find the magnitude and also the direction. Okay, B2. This question, they are asking for which combination will cause the largest turning effect. Okay, largest turning effect, that means I'm looking for the largest moment. And moment is force times perpendicular distance, right? So my force must definitely be large. Okay, my distance, I will try to be large as well, right? Okay, because the pivot is over here, my force is over here. Okay, and then now comes this theta. This theta is this angle over here. Okay, so if I were to draw, maybe I draw two cases whereby I have the angle as large. If it's large, that means this is the reference line. If it's large, it looks something like this, F, right? Okay, so this is when I have a large angle versus a small angle. This is the reference. Okay, and if I have a small angle, it looks something like this, and my angle is very small. Okay, so same thing, we just draw the line of action of the force. We draw the line of action of the force. Okay, just take a ruler, put it against the force and extend it front and back using a dotted line. And you see that the pivot is over here. This is the line. So where is the perpendicular distance? It is the shortest distance, right? So this is the perpendicular distance. And you see that this perpendicular distance is this amount. How about if it's when my angle is small, right? If my angle is small, so we have this and we see that this angle is small, right? So again, we draw our line of action of F, line of action. Okay, so the pivot is here, the line of action is here. Which one is the shortest distance to from point to line? It will be something like that, and it will definitely give us our perpendicular distance. So you see that this distance versus this distance, the second one whereby the angle is small will get us a larger perpendicular distance. And since moment equals to force times perpendicular distance, and if we say we compare the force, we keep it the same, okay, then the one with the larger perpendicular distance will have a larger moment. So your answer is A. Okay, for B3, we see a rectangular block of wood resting on the ground as shown. Which of the following is the easiest way? When we're talking about easiest way, we are looking for the largest moment. So again, largest moment, it depends on your force and distance combination. And because the force is all the same, that means it all boils down to whoever has the largest perpendicular distance will have the largest moment. Okay. So this question requires you to have some kind of imagination, or you can even use your pencil case or calculator. Imagine if I were to apply a force this way on this corner. So where will the pivot be? The pivot will be here. Okay, please try it out with a calculator. Okay, and you apply the force here. Okay, you set it on a level ground and you apply the force this way. Okay, the pivot will be over here. Okay, so the next part is to determine the perpendicular distance. So what's the first thing? You need to draw your line of action of the force. So this is the line. This is the point over here. And therefore, this will be the perpendicular distance. Let's do for B. So again, I apply a force on this corner, but instead of pulling it down, I'm pulling it up. So again, the pivot will be here. Please try that out. Okay, so if I have my force and I draw my line of action of the force, the pivot is over here. Therefore, this will be the perpendicular distance. So far, it seems like A has a larger perpendicular distance than B. Okay, don't believe, you can actually measure it for yourself. How about for C? So if I were to apply the force here, again at the same corner, okay, so you'll see that the pivot will still be at the same place, right? So I draw my line of action of the force, okay, and pivot here. Therefore, this will be the perpendicular distance. And seems like C has the largest so far. Okay, lastly, let's do D. Let's check. So I apply the force here, but I am going in this direction. So again, draw my line of action of the force. And if you simulate on your calculator or on your pencil case, rectangular, you will see that the pivot is now over here. Okay, pivot is here, line is here, the perpendicular distance is this. And therefore, D will be the answer because the perpendicular distance is a hypotenuse of this triangle. Okay. Okay. Success criteria C. State the principle of moments for a body in equilibrium. In equilibrium means the body is stationary. Okay. Or not moving. Okay. And also not rotating. Okay, which I can then sum up into two cases. You have learned that F net is equals to 0. Okay, and also net moment is 0. Okay, so I'll explain more later on, but you need to memorize this principle of moment. Okay, it says that when a body is in equilibrium, the sum, which is you add up. What do you add up? You add up all the clockwise moment about a pivot is equal to the sum. Okay, again, you add up what you add up of anti-clockwise moment about the same pivot. That means with this same pivot, if I have a pivot here, right, you have played with seesaw before, and in order for this seesaw to balance, the sum of clockwise moment must be equal to the sum of anti-clockwise moment. So basically, when you played seesaw in your younger days, you have actually applied the principle of moments. Okay, so that's all for success criteria A, B, and C.